In this video, I want to share some general comments about mathematical modeling and in particular modeling with differential equations. So what do we mean by a mathematical model here? Let me write this down. By a mathematical model, a mathematical model, we typically mean an equation or a set of equations, a collection of equations that describe describes some phenomena. Having its origin in science, engineering, economics, or some other area. Now, in the context of the differential equations, when I use this term modeling, I typically mean finding a differential equation that describes the given physical situation. Let me also write that down. In the context of differential equations, in the context of differential equations, DE, our abbreviation for differential equations, the term modeling typically means finding a differential equation that describes a given physical situation, a given physical situation. Of course, there is much more to mathematical modeling than simply finding an equation. This mathematical modeling is a process. It includes several steps. One step will be finding the equation. Let me also talk a little bit about that. Mathematical modeling is a process which includes several stages. So one stage, maybe the first stage, is to identify the problem that you want to study. Carefully describe the problem that you want to study. Identify the quantities that are of interest to you. So one of the stages will be identifying the important and relevant quantities, variables, and relevant quantities involved in the system that you are studying, involved in the phenomenon under consideration, that you are studying. Understanding the problem and identifying the variables that are of interest. And of course, then you have to make certain assumptions, model-specific assumptions about the quantities that are involved, making model-specific assumptions about the quantities involved, the quantities involved. And the third stage, after you know your variable, after you identify the variables of interest, after you clearly state the assumptions that you're making in your model, then you can develop the equations, derive the equations that describe the phenomena that you are studying. 3, deriving a collection of equations or inequalities. These equations do not necessarily need to be equalities. They may be inequalities that describe the quantities of interest, And of course, once you have your equations, the next step is to solve the equations, either finding the exact solutions or finding approximate solutions. So for solving the model equations, by some analytic or numerical method. Here I'm using the term analytic method to refer to those methods that give us exact solutions to the equations. And the term numerical methods here refers to those methods that provide approximate solutions to our equations. And then finally, once you have your solutions, you compare the solutions with the real data, comparing the solutions to real data, interpreting the results, see whether they match the data that were collected from the actual physical world. And if necessary, if you see that they do not match, maybe you need to change your assumptions. Maybe you need to modify your model. So, and modifying the assumptions and constructing a new model if necessary, and constructing a new model if necessary. If we see that the data does not approximate the results of our solutions, they do not approximate the real data to the degree of accuracy that we desire, obviously that means that this model is not a good model. Maybe we need to change certain aspects of our model, starting with reconsidering the assumptions that we made about our variables, if needed. Awesome. So of course, in this series of videos, I will not address all of these items. Our focus will be mostly on finding a differential equation that describes the given physical situation. with certain simplifying assumptions. So the videos that we will see, they will not be about all the stages that you see here. We will mostly focus on how we can derive a differential equation about the variables of interest based on certain simplifying assumptions.